battery boxes. So I've started to assemble the first battery box. I've got the 6 modules into this one, and I started to bundle up the BMS wires, and today I'm going to be splicing them because the original setup I did for testing, I did them at full length because I didn't really know how long they would need to be. But now that I've got them in here, I can kind of see just about how long I need these bundles to be. And so I will start to cut them and resplice them so that they're the right length. So it's a lot of wires, as you can see. It's gonna take me a little while. Gotta be methodical and do one wire at a time. It's very, very important that the exact right wires are always connected to each other. You don't wanna mix and match at all, or else that could be catastrophic for the batteries. So I'm going to dig into that today and hopefully make some progress. So first things first, get this huge nest of wires organized. I'm going to go into time-lapse mode so you don't have to watch every cut and every splice. You're welcome. So I'm making my way through these, making them shorter. Trying to measure each one to get it to the right appropriate length. Also don't want to do them all at the same point because these connectors are a little bit thicker, and if they're all bunched at the same time, they're just going to create a really thick knot. And we don't want that, so I'm just trying to stagger them a bit as best I can. Try to untangle them as I go. Then I take one of these little connectors, thread it onto there, strip about 1 centimeter off of each wire, and then this is how I do these little junctions. Is I bend the end over into a little hook, and then I can take the two and hook them together, pinch them so they're kind of tight there, and then take this connector and slide it right over the joint, centering it right in the center. Now these are shrinking connectors, so they take some heat, they shrink down. These 2 red stripes are glue that melt with the heat, and the center is a little piece of solder which melts and then solders the joint together. So the glue hopefully makes it waterproof. As well as staying in place. And you can see when the solder starts to melt, it gets nice and silvery in there. So there you go. I think that that's a pretty good joint. The glue has melted, and I can see that the solder has melted to the wires in between. So that's what I'm doing with each and every one of these. Just get that solder to go. There we go. So it's really not a very difficult process. It's just a lot of them. And you gotta do them one at a time because, like I said, it's really important that you get them connected correctly. So you only have one cut at a time. You know exactly where it's supposed to attach to. I'm back to working on assembling this first battery box. I've got all the components. I think I've got all the nuts and bolts that I need and all the wires that I need to do it. And it's just a matter of getting in there and doing it all and getting it all packed in there. It's been quite a long time actually since I was working on this. I took a break to work on some other things. So now I'm getting back to it, and hopefully I can pack this thing up pretty quickly now, and I can move on to the second battery box, which should go a bit quicker because I'll know what I'm doing. So I've got to get the contactors connected, the fuses, the various types of connectors, and I've got the BMSs basically wired up. They've got to get connected, and they've got some communication wires that have to get connected correctly. And yeah, so, you know, it's all got to be wired perfectly right to work, obviously. So it's not a small amount of pressure on getting everything done correctly. And I'm trying to test it as I go, so far successfully. You know, if one wire comes loose somehow in the process, then it could all fail, which is, you know, bad. But yeah, I think it's pretty solid. I think I've done all the wiring pretty well so far. So I'm just going to get into trying to mount things and connect them correctly and safely. Safety is always important. Be really careful. I've gotten the first contactor now mounted in place and connected to battery pack number 12 right here. And it's only connected at the positive. The negative is unconnected to anything. So at most I have the 25 volts of this one pack live. And so if I touch the positive of this and I touch a ground, we probably get a 25 volt shock. That's not technically considered deadly. It's not technically considered high voltage. So it probably will be fine, but I'm still gonna try and be really careful and not touch that and touch anything else that could be grounded. And then as I go through, I will connect the ultimate negative post of this pack to the contactor, and still the back end of it's not connected to anything, so it's still only 25 volts in this one. But once everything's connected and everything is basically how it's going to be on the front of the box, I will then put the bus bars in to connect all the packs in the back. And then at that point, it'll be live, where this connection, this contactor over here, and this connection to this contactor over here have the full voltage of this box, which is mass or minus 25 volts per 6. So that is 150 volts. It's actually probably more because they're charged up now. So yeah, it's close to 175 volts. So that is definitely high voltage. So at that point, I will have to be extremely careful and deliberate on how I do any work inside of this area, knowing that there's live voltage present. But for now, nothing's connected. There's no live voltage really, so it should be safe. All right, I've got the fuse for this box right here, and here's the contactor, which is normally open, and then this is the bus bar that's going to connect these two. And it's cool now that I'm at a point where I can actually lock these down. Flat washer first, then lock washer. You want to make sure you have a really solid connection between the surfaces of the bus bars and the contacts of the components, because if that connection, that contact is at all compromised, then you will not get a very good electrical connection. I actually have this electrical socket set, which is fully coated in plastic. There's no exposed metal anywhere on there, so it is rated up to 1000 volts and should keep me safe, even though, as I said, this is not currently live with anything more than 25 volts. Now that should be a good, solid connection there. So this is a high voltage connector. It gets mounted through this sort of front panel, and so that this contacts on the inside, this socket's on the outside, which there is metal inside there, so if you reach somehow your pinky in there, you could get electrocuted, but it's got a plastic cap out here and plastic surround, so it's very difficult to accidentally make contact with that on the outside of the box. You know, you could be really stupid and take a metal screwdriver and stick it in there, but we'll remember not to do that. I think that's the best policy, honestly. So what we're gonna do is attach this side of this bus bar to the fuse there, and then this connector goes there. Yeah, that's gonna work. So I can see right now I already have that problem that I was talking about, where I've got this electrical tape, and that electrical tape is going to overlap the connection, the sandwich between that and the fuse, and that is going to cause problems for sure. So what I'm going to do is take this electrical tape off, and I'll probably put some new electrical tape on there, but just not as wide. So I can go as far as that. These bus bars are made of thin sheets of copper. This is 4 of them sandwiched together. It makes it bend a lot easier. Okay, let's see what happens if I crank this down now. And then this will connect like so. I just need to bend it into place a little bit. Let me get some pliers. Still needs to come forward more. All right, I think that's the place for it. That looks really good. Now I'm really happy that I got these flexible bus bars, because working out just the right distance of this is tricky, and the fact that I can bend them really makes it a lot easier. So you can see, comes from the battery here. This is the contactor, which is a big switch controlled by these leads. When the car turns that switch to the closed position, charge can go through here, through this big fuse, down this bus bar to this connector sitting on the outside of the box. So on the outside of the box, this will be available, and then this will be connected to the power cable, and it should be able to just basically slide in there. And then that's a nice, safe, high voltage connection. Can only be released by pressing down this button here. There we go. Okay, so that is that end. Now I have to connect up this end, which then this needs to connect to the negative terminal of this pack, and this contactor has to be screwed into place and locked down, and then we'll have all of those components in place. I'm about to drill the first hole for one of my connections through the front plate of the battery box, and I'm really nervous about it, but there's no going back if I make a mistake, but we'll see. So this is the right size hole. I'm going to double check that. This is a measure twice, cut once situation. So yeah, that's the right size hole. And let's see. Okay. Well, that's a pretty nice, clean hole. That's good. Oh, that doesn't look too bad. So this is going to slide right in like that. And I've got to center it and drill small holes for some bolts to hold it in place. And I have to make 2 more holes for the high voltage positive and negative terminals that are going to come through. That's going to be a little bit trickier because they have to be positioned exactly right, because they have to line up with the bus bars on the inside to connect properly. So I'm going to have to go do some precise measurements of the exact location to center those holes on. That's going to be a little tricky, but I have an idea about how to do it. Okay, now with the high voltage terminals bolted into place internally where they're going to be attached to these bus bars, I tried the best to get them nice and flat and flush to the surface, and then I can measure their spacing, hopefully by lining them up. And I can use this to kind of line up the bolt holes, which will help. Okay, I've got a square marked out. Now I'm going to try and get the center of that square just right Okay, that's pretty good. Diagonal from corner to corner. See if I can get another one of those. Not quite, there we go. Okay, well, that is going to be the beginning of that. Well, we're going to see just how good my measuring can be. All right, here's the receptacle. It's going to go right in there. I have to be entirely sure that I get the right hole shape. It's going to be this one, which is just wide enough. Moment of truth. Sure goes through easy. Yeah, that's gonna work. It's tight, but it works. It gets through there. And then when I screw it down, it'll be nice and stable. Now the big deal is, does it line up with the bus bar? That looks really nice. And it's pretty centered with the lines I drew, so that's good. So when this is permanently mounted, this will in fact be bolted to the plate, so it will be on there solid. I'm back from just making that hole just a tiny bit more wide, and yeah, that just goes over and gives me a little tiny bit of wiggle room, which is important. All right, well, I drilled that hole out, so now it goes over it, but I also bent this a bit and mangled it a little bit. Oh boy, okay, so hope I didn't screw up this bus bar completely. But probably not. Okay. I need to bend it quite a bit again though. This is a problem, but we're going to fix it because it fit before and it will fit again. Okay, it's not far, it just has to twist up a little bit and it will go into place. We're gonna make this work. Tighten that down a little bit, give it some rigid strength, and then I'm gonna go in there with this plier. Okay, that goes on there. Let's line these bolts up if I can, though. All right, that's so close. Let's just put a couple of these in. Okay, so front plate is lined up. Now it's just a matter of getting this. Hear that? That is the bus bar going on to that. Now, if I can get these on there. I think I can use the strength of these bolts to actually tighten down the bus bar. Man, I was worried that I really messed it up by bending that bus bar. But I don't think so. Tightening this on now, I think I'm getting a really nice sandwich of those copper pieces. That's rotating just a little bit, but that's okay. And then if I tighten this down, all right, take a look at this. That's the first terminal installed. There we go. So that is a high voltage, highly safe connection. The cable coming out of there should connect to all the current inside of here and pop off like that. But pretty happy that this worked. Telling you, it was not a sure thing there for a minute. Seemed like I might have messed it up. But I think but I didn't. It's gonna work. Excellent. Well, we are just about done with this first battery box. I've got the terminals all mounted and they're in the right place. Everything is ready to connect in front, and I just need to add the bus bars to the rear, which will then connect all 6 of these packs together. So this is getting to the critical juncture. When I add these 2 bus bars in the pack, then all 6 of these packs will be in sequence, and the full voltage of this battery box will be online, which means it'll be almost 200 volts. And so that's where I have to start to get very careful when I make the final connections. The first thing I'm going to do once I get them connected in line is I'm going to retest all the leads that go to the BMS and make sure that all the connections that I've run throughout here are all still well connected. So I have all the BMS will work, and then I can plug them into the BMS units. Once that's all connected, the last thing to do is make the connections to these terminals and attach the front plate on. It's nerve-wracking because this is like truly the dangerous stuff. And And so I've got my high voltage gloves ready, and I'm gotta take the safety covers carefully off of the terminals back here. This is pack 11 positive connecting to pack 12 negative. Okay, that's pretty good and tight. And then I'll put these back over. This is the final bus bar. Shit. Okay. That's on there now. These covers on. Now we should have full connection all the way through. Guess there's only one way to test that. So now I'm going to do something to try and test this, which is potentially, let's see, I'm going to be very careful about this. And I'm going to connect that to that terminal there. Okay, so using only one hand, wearing rubber-soled shoes, wearing my gloves. Now I'm going to touch this to the negative terminal here and see. Okay, it says 170 volts. That's just about right. I'm doing a test here now that I've got the front plate completely wired up and connected. Now I've connected the power that will initiate the contactors there. And when I flip this switch, the contactors should close. It sounds like they did. And now I'm going to test the voltage in these very carefully. 170 volts. I'll let you see that first. Okay, 170. Zero. Let's see if I can leave that in there. Yeah, 170. Zero. It's looking good. Now I can put the top cover on and call this box complete. Wow. First battery box. So this is legit the first time that I have closed up one of these boxes, and it all looks amazing. It looks like what I expected it to look like in the 3D models. And wow, that is a full battery box. In fact, if I had both of them, I could throw them into the car like this and have power. Before I do that, I'm gonna seal up all the panels, but other than that, all the wiring is done. Now, they are heavy, but they're not so heavy that two people can't lift them. So I think that is good news, meaning I don't need like a crane or something to come in and pick them up. And I'll say they're looking really, really tight.